Okay, in this video we're going to go a little bit more in depth with strings, the data type strings. There are some built-in functions with strings and some various different things you can use to manipulate the string data itself. Okay, so last time we've been taking notes here. We made a few different programs with conditional statements. I'm going to add a new file here and call this strings.py. Okay, and we're just going to make a little program here. Alright, so first we're going to talk about letter casing. Okay, so we know because of the ASCII character encoding that there's a numeric representation or a numeric value associated with every character symbol that we have, right? So when I type the word hello in all uppercase, the actual binary numbers that are representing these letters are different than if I were to have typed hello in lowercase. Alright, so there's built-in functions in Python that allow you to change the casing of a particular string. Alright, so this, everything in quotes, is a string literal. Okay, all string literals have additional properties on them that are, in this case, functions. So the dot operator after a string literal, or any object in Python, the dot operator accesses additional properties that might be on that object. Okay, so hello is a string, but it actually has additional things attached to it, and you can access those things with the dot operator, or the accessor operator. So dot lower and the left and right parentheses is going to take this string as input, and then it's going to return a lowercase value. Okay, so if we want to see what the value of that is, we need to print this whole thing. Alright, so we've got strings. We're at the desktop here, and I'm just going to run Python 3 strings. And sure enough, we get hello in lowercase. Now we can access any string has these properties, these functions attached to it. Okay, so we can store it in a variable if we prefer, and then just reference the variable dot lower. Okay, so let's add a string that is mixed case. Okay, so somebody might enter that data, and we want to print out the lowercase version. So S is a variable identifier holding a string. Attached to all strings, there are additional properties. These properties happen to be functions, and they take the string itself as an input, and they return a different string. Okay, so s.lower, whatever's stored in S, is this mixed case string. So this is going to return the lowercase version. S will still hold the mixed case version. Okay, so I'll print out S at the beginning. So there's our hello. This is S by itself, mixed case version, S.lower. Alright. Then we have S.upper. We want to print that out as well. So that gives us all uppercase. Then we have capitalize, S.capitalize, which capitalizes the first letter in the string and puts everything else lowercase. Okay, so the first letter in the entire string is uppercase, but notice even the E here at the end in another word, that went lowercase. Everything else goes lowercase. Okay, so this is convenient when you have like a single name, like somebody's last name. You just hit capitalize, like dot capitalize on it, and then you know for sure it's formatted correctly. Alright, and then one of the other ones is title casing. So this is like the title of a book or a chapter, and it capitalizes every word in the string. Okay, so this, if you had a book called Apple Pie, or a recipe book, right? capital A, and then a capital P. That's title casing. So these are the four main types of casing that you can use, and it's built into the string. See here we accessed it from a string literal dot lower, or you can save that string literal in a variable and say s dot lower. And I'll print out s one more time just so we know that the value of s did not change. Each one of those functions returns a new string. So s still is the mixed case version, but it just returns a different version of the string. Okay. We can only change what's stored in s with a new assignment. Okay. So that's letter casing. Now let's look at the strip and replace functions. Okay. So in Python you might have a string and you might have some extra white space at the beginning. 1, 2, 3, 4. Okay, so I have some white space here at the beginning. I have 2 extra white spaces at the end and 4 at the beginning. 1, 2, 3, 4. Okay. So first of all, if I want to know how many characters are in my string, I can print the length of the string. Okay. And when I print things out, I like to label them. So I'm going to put a little label here. Colon. Alright, so this is the first argument to the print function. It's going to print out length of s colon, and then it's going to add a space because it adds a space between arguments, and then I'm actually going to print out the length of my string. Okay, so the length of s, the length of my string, is 56. So that means there's 56 characters in here. Alright. So I'm going to go ahead and print out s. Run that. Then we see the spaces here. And even here at the end, we see there's the 2 spaces there at the end. Alright, so if I want to strip off those spaces, I can make a new variable here and say s.strip. Okay, s is the input string, so this is the input, and then I'm calling dot strip on it, just like we call dot lower or dot upper or any of those. The string itself is the input, and then we call the function dot strip, and that strips off any white space. So I could have a tab character or new lines at the beginning and at the end, but doesn't mess with anything in between. It only messes with stuff at the beginning and the end. Okay, so s1 is going to equal s.strip. Okay, and we're going to print out the length of s1 so we can compare. So that's the length of s1, and then we're going to print out s1 and we can see it visually as well. Okay, so we see the length is now 50 instead of 56. There were 4 white spaces here at the beginning and 2 at the end, so that's 6, so it should be 6 less. And when we print it out, we see that S1 no longer has the spaces. Okay, that's what strip does. It strips off the additional white space characters. And this again will work if I had a /tab character and then a couple new line characters here. It'll strip those off as well. Okay, see here we have the 4 spaces, the tab character automatically, see it's just one character, but it prints it as one big block, okay? And then we have 2 new line characters, okay? So that's 6 plus a tab character plus 2 new lines, that's 9 characters. So this one's 59 characters, and this one's 50, okay? But it just strips off white space. Oops. Alright, so now for the replace. Alright, so I can make another string s2, and I'm going to say that is going to be equal to s1 dot replace. And what do I want to replace in this string? I want to replace Sally, the string Sally, I want to replace that with Jack. Okay, this is going to return a string. So let's print that out. So every instance of Sally is now Jack, right? So Weeping Angels doesn't really fit here. That's a Doctor Who reference. So Jack Sparrow needs to be aware of something else, right? So beware of the Kraken. So s1.replace returns a string, okay? Just so it eventually, when it evaluates, it becomes essentially a string, which all strings have these properties. So I can go ahead and call .replace again, because this whole thing is a string essentially. All right, that's important. This is called chaining. We have a string here, s1, and we call a method on it that returns a string. So this whole thing is a string, which means it has a method .replace, and that returns a string. So I could call replace here over and over and over and over again. Each time it's called, it returns a different string, and then the final output of the entire thing is going to be stored in S2. Alright, so what we're going to replace here is, instead of Weeping Angels, we're going to put Kraken. Kraken. I think that's how you spell it. Alright, we'll print that out. So we can see we replaced all the instances of Sally with Jack, right? And then all the instances of Weeping Angels, there was only one, with Kraken. Alright, so that is strip, takes off the white space, and Kraken, or replaces the first parameter there to replace is what you're looking for in the string. So Sally, we're looking for all of the instances of Sally, and we're replacing it with all of the instances of, or replacing it with Jack. And then here are all of the instances of Weeping Angels, and we're replacing that with Kraken. All right. So that's find and replace. Let's reference characters in a string. Okay. So if you have a string of characters, really what you have is a list of characters, right? You have multiple characters in a row, and I can have any number of them, right? But essentially it amounts to a list. It's just a list of characters. Okay, so we're gonna call this one, let's see, reference characters in a string by their index number. Okay, so these hash symbols, of course, are comment characters. Python ignores any line that starts with a hash, right? So these are just headings for us to look at when we're looking at the code, right? So if I want to reference characters in a string by index, let's start with a string called alphabet, or alpha, that has all of the characters in the alphabet: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z, right? So we can verify that that is all of the letters in the alphabet, or partially verify with printing out the length of alpha. So again, this first argument is just the label. That's just a string that's actually going to be printed verbatim to the terminal, and then this is going to be evaluated to the actual numeric value. Alright, so the length of alpha we see is 26. Alright, another way of writing that is I could say length equals length of alpha, and then just do it this way. So in this case, I'm storing the value of the length of the string in a separate variable called length, but it's going to print out essentially the same thing. Okay, so the length is 26. All right, so let's go ahead and print out a couple little dividers here so we know where we are. And let's print out our alphabet. Alright, there we go. Those little dividers tell us where we are. This is section 1, section 2. Now we're on this alphabet. Okay, so we want to reference individual characters from inside of this larger string. Okay, we can do that by reference by index. Okay, so the indexing in computer science always starts with 0. Alright, so if I want to access an individual character, I reference the string, the variable holding the string, so alpha, and then I have to use square brackets. Square brackets mean I'm accessing one of the items inside of this larger object, inside of this collection. This is an item that is actually a collection of characters. So a string is kind of like a list of characters, right? So if I want to reference the first item, that's the item at index 0. Right? So if I run this, see that prints out A. All right, so let's do our labeling thing. I'll copy that and put quotes around that. Oops. Okay, so alpha 0 in alphabet, the first item is index 0, so the second item is index 1. Okay, so again, we print out our label, square brackets. What goes in the square brackets is the index, and that can be a calculation too. You can do mathematical operations in here. So this is alpha 1. And that should be the letter B. Indexing starts at 0, so A is index 0, B is index 1. And you could go on and on like this. And then this could be 23. 24. And 25. Now there's 26 letters in the alphabet, but we started the index numbering process at 0, so that means 25 should be the last item in our list. So A, B, C, sure enough, X, Y, and Z. Now if I try to do one more, this is just to make it look nice in the display. If I try to do one more, duplicate the line. We'll go 26. Now we should get an error here. Python doesn't like it when you try to access a member of a list that is outside the size of that list. So this is a list of characters, right? A string is basically just a list of characters. And if I'm trying to access something in that string, if the index is outside of the bounds of the actual string, so here I'm trying to access the item at index 26, which does not exist, Python complains, and it's going to give us an error here. String index out of range. Okay, so it's outside of the allowed range because there's only so many characters in the string. Right? And again, it tells you what file it's in, strings.py, what line number, line 52. So we go down here and look, sure enough, line 52, this one's out of range. Okay, so we can remove that line. Alright, so what I can do here is if I wanted to print out cat, I can say alpha 2. So index 2 should be, if this is 0, 1, 2, the item at index 2 should be a C. And I'm going to use string concatenation. Okay, so I'm going to use the plus sign, and then alpha, I want an A, so that's 0, and then I can say alpha And let's see, what's T going to be? Let's guess 19 real quick and see if we're right. Yeah, there we go. Ooh, that's a good guess. All right, so T is the 19th index, right? So this is 20, 21, 22, 23, 24, 25, and we already know that Z is 25, right? So this is cat. And you spell that out by referencing individual characters in this string. So alpha, square brackets, and then the index. And this can be an expression. It doesn't just have to be a number, it can be an expression. So a variable holding a number, or you can actually do like, 2 plus 1 minus 1, right? So that should just equal 2. We shouldn't see any change, right? 2 plus 1 minus 1. All right, so that's still cat. All right. Another nice thing you can do is if you don't know how big your string is and you need to find the last item in the string, you can use the length to find it, right? So the length of the string is 26, but the index of the last character is 25. All right. What if we had a string of length 1, right? Say we had S equals just one character. Well, the length of this string is 1, and the index of that is 0. So the last item in a string or a list is always the length of that string or list minus 1, right? So let's look at AB. The length of this is 2. This index item, if A is 0 index, then B is 1. So 2 minus 1 is 1, and that's correct. All right, so if I want to use that, I can get the last item in the list a couple of different ways. Let's see. Let's just do label it last first. Alright, so what I want to do is I want to take the length of alpha minus 1. Okay, so what's happening here? I'm referencing one single character in the alpha variable, which is this. I want to reference one single variable, so I have to have the name of the string and then square brackets. Okay, inside the square brackets is the index that I want. I want the very last item in this list, regardless of how many items are in the list. Okay, so if I say length of alpha, that's going to be 26. All right, the last item in the list is index 25. So I want minus 1 there. So this whole thing here is just an expression that evaluates to a number. Okay. So the last character is Z. Now watch as I type some other stuff in here. Since I did it this way, I added some additional stuff. I still want the last character in the string. This is always going to be the last character in the string. So this should be Y now. Okay? Because I use this calculation. If I would have just said print out 25, see up here I print out 25, and that's still Z. The item at index 25, that's the 26th character in the alphabet, is Z. Right? Here I'm getting the very last character of the string, regardless of how many there are. Okay, so the length of the variable minus 1 is something real common that you're going to have to do. So reference the variable itself, square brackets to reference something by index within that collection, and then the last item in the collection is going to be, the index number is going to be length of that item minus 1. Okay, you can also use that variable that we made, the length variable. So instead of doing it like this, what we can do is say length. Oops, caps lock. Alright, so we already called length of alpha, right? Up here, length of alpha, we stored that in a variable called length. So we're just going to use that variable instead. and you see it's the same thing, right? We still get a Z. So Python has a shortcut for this. It's really nice, and it's a really common thing to want to do. So it allows you to reference things by index and by negative index. Okay, so the last item in a collection or in a list or in a string, the last character in the string has a value of -1. Right? So I don't have to write length of alpha. Most programming languages do not have this feature. Python is really nice. In every other programming language, or most other ones, you just have to write length of the thing -1. So it's more typing, right? It's not really that big of a deal, but it is kind of nice. It's a nice little shortcut that Python provides. Just remember, most other programming languages won't have that. Okay, so we get the last item. I could also do the second to last. And just do -2. Okay, so square brackets and then the index number inside. Okay, and that has to be an integer. I don't think floats will work, but they might. Let me check. Python 3, let's say we have a string, and I want to access s 1.0. Yeah, indices must be integers. Okay, so they can't be strings and they can't be floating point decimals. They have to be integers. Alright, so now we can get individual items in the string, right? We got individual characters and we spelled out cat, right? And everything inside the square brackets is just an expression that evaluates to an integer. Right, so now let's look at something else we can do called slices. These are string slices. So I can have some variable s and say it holds the string literal slices. Okay, so this is kind of a little chart that I've made to illustrate the index values. So here's our string slices, right? And these are just separators between the characters for illustration purposes. So this is our string, and then here's the index of each character in that string. So here the first character S has an index of 0. The second character L has an index of 1. I has an index of 2, C 3, E 4, and S 5, right? Now we learned about the negative index. So the -1 is always the last item in that string. -2 would be second to last. -3 all the way to -6, which would be our original S. Okay? So this is the stuff we've covered so far. Now we're going to talk about slices. So when we talk about a slice, think about slicing a loaf of bread. Okay? Each slice of bread is one of the characters in our string. Okay? And the slice index itself is always to the left. It's always right before the index you're talking about. Okay, so what I can do is I can take a slice of the strings, and the slice basically allows me to take a substring. So if I have the string slices, I can say I'm going to print out S from 0 to 1. So we use square brackets again, but instead of an expression that evaluates to a single integer, this is two expressions separated by a colon. So this is 0 going to 1. So that's going to grab all of the characters between these two slices. So here this is slice 0 and this is 1. So it's going to grab all the characters between those two slices, which is just S. Okay. So if we print that out, I'm going to add a little label too. Oops. Alright, so grabbed all the characters in string slices. So let's go ahead and just print out S2. we'll print out our divider here too. Okay, so now we're on slices. Our string s equals slices. The variable s, then square brackets, and you have two expressions separated by a colon. So this is the first expression. This is a simple one. It's just an actual number. And then this is the second expression. That's a simple one too. It's just an actual number. All right. So I can take a more complicated slice. Let's find. Well, first I can substitute 0. Instead of using 0, I can just leave that first expression blank, and that means go from the beginning of the string. So start with your string name, string variable, so that's s. I want to start my slice from the beginning of the string, so I can use 0 or I can just leave it blank, and then I can say 1. And this should also be the character s. Okay, we left it blank. So if it's blank, it assumes it's 0. Right. So the next on the list is let's get more than one character in our slice. So print, let's say we want to print out ice. How can we do that? Well, we want to get the characters from the string s, and we're going to have to use square brackets. And there's going to have to be two expressions separated by a colon. Okay, so the first expression, we want to print out ice, so here is I. We want the slice right before that, so that's going to be going from 2, and then we want the slice at the end, so to 5. So these are the slices, the two slices. Take a knife and cut right there, and you take a knife and cut right there. Whatever's left in between is what gets printed out. So this is going to be going from 2 to 5. Alright. Let's do the negative index of that. Okay, instead of 2, we're going to do the negative slice index. That's -4 to -1. -4 to -1. So that's ice as well. Okay. So we can do, lots of different variations of this. You can mix them too. I can say if I wanted to print out lice, I would have to go back one character, so that would be to 1, and then 5 is really -1. Okay, so this is going to give me from index 1, which is here, that slice, all the way to slice -1, which is here. So it's those items. So that should give us lice, unfortunately. Alright, so we run that. There we go. And then if I wanted just slice without the S at the end, I could say S, and I want to start from the beginning of the list and go to the end of the list except -1, right? So I'm removing this. So the beginning of the list, I left it blank. Remember, there's two expressions here and then a colon. Beginning of the list, I left it blank, so that means start at the beginning. And then I can go to -1, which means go all the way to the end, -1. Okay, so that removes the S. It removes the last character. Let me save that and run that. Sure enough, that's slice. Okay. If I want slices with the S, there's a couple different ways I can do that. It basically copies the string over. I can say I want to go from 0 to this slice here is actually 6. So the length of the string, right? 1, 2, 3, 4, 5, 6. Remember, there's no 6 for the index. Not one of these characters has an index of 6 associated with it. But because the slices, there are more slices than there are pieces of bread, there's a slice at the beginning and the end, right? You see, every index here shifts over to the left at this slice, right? So every one of these shifts to the left. 1 over here shifts to the left to this slice, which means 5 shifts to the left over here. And we have one more slice. So this last slice is always the length of the string. So I can say length of S. So that should give us the whole string. Okay, and then there's a shortcut for that. If I want to start the string at the beginning, I can just leave it blank. And if I want to go to the end of the string, I can leave the second one blank. Okay, so there's two expressions separated by a colon, except we're leaving both of the expressions blank. And that means go from the start, and then this one blank means go from the end. And again, we still have slices over there. Okay, so that's slices. This comes up a lot in lists. Lists behave just like strings in this regard. Okay, and we'll be covering lists soon. Alright, so what we want to talk about now, this is the last big part of strings. We want to talk about formatting strings. Okay, so let's say I have a greeting, and I want to say this is hello, and then I say the name, this is going to be Luke. Alright, so I can make a variable S that holds this string, and this is going to be a formatted string. So I type the character F and 2 quotation marks. Normally when I save a string, it's just 2 quotation marks and I'll type whatever in here. Okay, but this is a special type of string. It's called a format string. So you have to have the F character right before the 2 quotation marks. Okay, what this allows me to do is I can interpolate whatever variables I have defined above. So I can say greeting, oops, capitalize, greeting. So I use curly brackets and then some expression that evaluates to something. Okay, so I can say greeting, and then I can say comma, my name is, and then name. Okay, so notice that the curly brackets surround something that you would think of as just a normal Python expression. Alright, and then I can add an exclamation point afterwards. So this is kind of nice. It's a little bit easier than trying to concatenate everything. So let's just print that out. I'm going to need my extra little line here. Hello, my name is Luke. Okay, so you see whatever variables I have defined, if I use curly brackets inside of the format string, I can just place them, I can just inject them in there. Alright, this is a little bit nicer than doing something like this. I could say S equals greeting plus comma my name is space plus name plus exclamation point. Right. Yes. This is the same thing essentially, but this is a little bit easier to read. Okay, you don't have all these extra pluses and all these extra quotation marks. Right? We can print it out and prove that they're the same. Right? They say the same thing. That's fine. All right, so let's. We need to fix that greeting. We need that to be capitalized, so we can say dot capitalize. Okay, so everything in here is an expression, right? You can call functions in here. You can call, use the concatenation operator. You can, if you have number values, you can add them and subtract them, right? So this is important because normally, if we had numbers in here, you would have to convert them to a string to add them together. All right. So let's print this one out real quick, and I'll show you what I mean with the numbers. So that capitalized the H in our greeting. Okay, so greeting is this variable. Greeting.capitalize returns a different string that is these characters with a capital H. Okay, and then since this whole expression is in curly brackets inside of our format string, it gets injected in there directly. Then we have a comma, and then my name is. So here, there's the greeting with a capital H, and then comma, my name is, and then name gets injected into the string, into the format string, because that's this variable, and then an exclamation point at the end. Alright, so this is kind of nice. I can it's important that at the time we create this string, all of this gets evaluated and a string is returned and stored here. Okay, so I can change the values of these things. I can say greeting instead of hello equals hi, and I can say name instead of Luke equals Earl. Right? So changing these variables after I've already executed this line of code will not change the value of S. So it still says, hello, my name is Luke. Okay, that's because greeting at this line of code, greeting was still hello. So when this line of code executed, this variable was hello and this variable was Luke. Now they're different, but S is holding a different string. S is holding the result of this format string, which has already been done. So now we change the value, print out S. It doesn't change S. We've changed greeting and name. So if I want S to change, I would have to run this line of code again. Right? So now here greeting has been changed to hi, and the name has been changed to Earl. So now since this line of code is running after these two lines, now we see that it will print out the new version. Okay? So that's format strings, and you can use that with numeric stuff as well. So if I had an integer x equals 10, I could say print, and I want to print a string, but I want it to be a format string, and I can say my number is x. That's a lot easier than the other way, x plus 1. Right, see, this is an expression. I can do any kind of math in here that I want. X plus 2 divided by 2. Put parentheses around that. Okay, that's a lot easier than the alternative. The alternative is my number is space, and then I have to add, but I can't add string data to numeric data, so I have to convert the numeric data to a string. Okay, and then I would add the exclamation point at the end. And then this numeric data, this would be x plus 2, and then parentheses around that, divided by 2. Print my number is plus the string of x, extra parenthesis. There we go. So this is the string function, right? So having too many parentheses is a common problem in computer science. Always count your parentheses, right? Here's the beginning parentheses, here's the end, right? Here's the next one, here's the second to last one. So every parenthesis should have a matching pair. Alright, so we run it that way. Right, if we don't have this string function here, we get an error because we're trying to convert, or trying to add string data to numeric data, and it doesn't know what to do. So it must be a string, not a float. Alright. So we see that basically this is just a quick way to write your strings, and it's kind of nice to be able to inject variables into your string without all of these quotes and plus signs, right? So I can see real quickly that this is the greeting, and I'm going to capitalize that real quick, and then I can have comma, the name is, and I can just add the exclamation point at the end without having to do something like this, right? And then also down here we see that you don't have to convert the data to a string if you use this format string. It automatically converts any data format it can to a string for you. So you don't have all of these extra calls. So it eliminates a whole bunch of quotation marks, spaces, plus signs, and str function calls. All right. So that's the basics for strings. Most of the stuff you're going to use for strings anyway. All right, so that's enough for one video.